Okay, we're back out here on my heat pump again. There's nothing wrong with this heat pump. I fixed it last year. Remember, if you watch my other videos, you know what the problem was and how I saved myself 850, almost 900 bucks by fixing it myself. That cost me absolutely nothing. Okay, and so that's what these videos are about. Listen, I'm not out here to step on any of these heat pump guys' toes. I got last video, a guy kind of got mad at me because I didn't tell you all what a hermetically sealed compressor was. All I wanted you to know was that it was a compressor that hooked to that other prong on the capacitor. You didn't need to know what all that was, but he took offense by it and made him mad. But really what made him mad was I showed him how to fix a $15 part that he wanted to charge you $400 or $500 to fix. I'm not here to step on anybody's toes, and I ask these guys that's watching this video, that's the heat pump pros, that's done this for years and years, please understand, some folks can't pay you the money that you want to charge for these jobs. I'm not saying you're not worth it. I'm not saying that all the schooling you went to and all these things you did in order to get your certificate to do these, it's not worth it. I'm just saying some people cannot afford it. You take an elderly couple my age, they might not have enough money to pay you $500 to do a job they can do themselves for 15, 20 bucks. So I just say remember that, please. So today, what we're talking about, remember again, there's our diagram. If you have any questions about what's what, that will tell you everything. And I may not use the same terminology as we found out in last video, so I got mad at me because I didn't say that this prong over here on the capacitor was hermetically, it says herm. All I wanted you to know was it says compressor prong. That's it. That because the other one was for the fan and the other one for the common. That's all I wanted you to know what those were. You didn't need to know what that meant, but anyway. So today what we're talking about is this thing, big black box. It's a relay. Now the heat pump guy is going to say, "Oh no, it's a contactor." It's a relay. It's the same. It's a relay. So first of all, I'm going to describe the problems that this thing can cause. I'm going to describe to you about this thing, what it does, and how it works. So as you remember from the previous videos, this board down here will receive a signal. See down there, it'll say H1 right now. Mine, it's warm enough outside. Mine ain't in no mode right now. It's just waiting. So if it was in heat cycle 1, it would say H1. It would get a signal from these wires here. And remember what those wires from my very first video, those come from your thermostat, right? Your thermostat sends a signal out here, and it's going to be 24 volts. Comes to this board, tells this board to go into heat cycle 1 mode. Heat cycle 1 mode then sends a signal. This board then sends a signal up here to this relay. Once this relay receives that signal, 24 volt signal, you'll have a positive side and a negative side over here. It does, you just use a meter. We'll test that here in a second. Mine's not going to have any voltage yet because mine's not in any heat mode or cool mode. But what we're looking for, if you remember these bottom two strongs, and I haven't disconnected the power right now, but I'm keeping my fingers. It looks a little closer on camera probably, but I'm keeping my fingers a good 4 or 5 inches away from these screws. But these bottom two screws here, right there, red and black, those are what's called your line voltage. Each one of those carries 120 volts. And then you'll have it grounded. If you'll see right over here, this green wire right there, that's your grounded to the frame of the unit out here. So you'll have 120 volts between this red one and this green ground. Then you'll have 120 volts between the black wire and the green ground. Together, if you measure voltage across those two together, it was going to be 240 volts. Okay. So what this thing is, once it receives, because this board cannot handle 240 volts. It can't handle it. It would fry that board in a split second. So, how can it keep the compressor on and that fan on from that kind of voltage? The only way it can do it is by using a relay. Contactor, as HVAC guys will call it. It's a contactor relay, same thing. It receives a voltage from these two wires right here. So yours may have 3 or 4 wires. That's fine. The only thing to remember is one side's positive, one side's negative. Okay, and that will be 24 volts across those two. So you'll put one prong here from your meter, and one prong over here from your meter. That should read 24 voltage. If you got a call for heat or cool down here, H1 or C1, And if it's not on right now, what you want to do is go inside your heat pump unit, inside indoor on your thermostat, and you'll turn your, say like mine right now is set on 72, but the temperature in my house is 73. So this unit can't kick on right now because it's warmer in the house than I got the temperature set to. So you need to turn your temperature up a little bit to make this kick on. So if this ain't kicking on out here, remember the problems we've had so far. We've diagnosed bad boards, we've diagnosed bad capacitors, and now if you check the capacitor, it's good. If you check your defroster board, it's good. If you're getting 24 volts out here and then to the board and then to the relay, all that's good, and all this is good so far, then possibility is it's the relay. These capacitors go out more than anything, and then probably the second thing behind those is the relays, contactors. They go out next. So it receives voltage across these two wires. Remember, there's one on each side here. This black one and that black one. Some of them will be red and yellow, some will be green, whatever it is. Doesn't matter the color. The main thing is you got a positive side to the coil and a negative side to the coil. When it receives that voltage from the board, it will kick that relay in. That little coil will suck down, close those contacts in there. That's why they call it a contactor. It'll close the contacts, and then voltage can flow from here, these two wires down here, up to here, and that'll send the voltage out to your fan and out down into your compressor, and that makes this outdoor unit kick on. So what can happen to these two? There's only two things I've ever seen happen to these relays. And this goes for car relays, that goes for these relays, any relays. Two things. One, the coil burns up that is used to suck the contacts together so it can send the voltage across, because you want volts to pass from here to here to go on out to the fan. Now, this is called a single pole. We'll get to that in a minute. So, only two things can happen. That contactor could go bad. In other words, the coil. The coil could go bad and it won't suck that contact closed, and so the voltage can flow. The second thing is, after many cycles, click, 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 after many uses over years, it's sitting there sucking in, sucking out, sucking in, sucking out. You know, clicking in, clicking out, clicking in, clicking out. This little button right here. After many years of that, those contacts inside that unit, some of these are sealed and some are open. This is a sealed unit. As you can see, you can't see the contacts in here, but where my finger is, if it's an open unit, you can see the contacts. Those get dirtier easier. These still get dirty, just metal wire. And what happens is over time, those contacts gets corroded over. And so even though the coil is good and it goes and sucks it together, voltage still can't flow through because the contacts are corroded over, kind of like a battery terminal on your car. It gets corroded and voltage still can't flow even though the contact is closed, right? That's the two things that can go wrong with this relay. So, how do we check it? It's very simple. There's several ways to do it. The way I like to do it, if I'm getting 24 volts right here on each side, from here to here, from the board, if I'm getting 24 volts on the side, that's the coil. Remember, these two smaller wires here are your coil wires coming from your board. Those two wires right there are the wires that tell the coil to click on so the voltage can pass. I check voltage on those. First of all, though, you got to remember, you got to have a call for power. In other words, you'll see H1 here on this board or C1 on this little board. If your board doesn't have either one of those, it's an older board and doesn't have that little thing down there that shows you H1 or C1, that's okay. Just go inside, turn your heat pump on, raise the temperature until you hear the indoor unit kick on. When the indoor fan starts blowing inside your house and you can feel air coming from your vents, then come out here. And you know, you already know because your outdoor unit ain't working and that's why you're looking at it. And then come out here and check voltage here on these two terminals across this way. These two wires right here, right? This little black wire going to one side, not this big yellow wire, this little black wire, and that little black wire. That's your coil wire. Check your voltage. It'll say somewhere, they say 24 volts, that's what it's rated at, but it usually ends up being around 25 to 27 volts, somewhere in that area. But we'll call it 24 volts because that's what it calls for. So you will check that. If you do have 24 volts here, and this button, see this little black button right here, I can barely press it in right here. If that hasn't pressed in, then that's another indicator that the coil is either A, receiving voltage, or the coil is burnt out. So all you got to do is check the voltage here. If you have voltage, but this coil, this little button isn't pressed in, I hope you can see that. Let me get a little closer. Right there with my fingers. See, I can push it and make it kick on. Watch. You hear that kick on? So if that button doesn't pop in and kick the unit on, then that simply tells you that the coil's probably bad. That's almost 100% dead giveaway. That coil's bad. If you don't have voltage here, then we got to go back to what we did before. It's either your board, your wiring, or the thermostat inside. One of the two, one of the three. There's nothing else. It won't be the capacitor, because if you don't have voltage here, it simply means you're not getting it from the board. And if you're not getting it from the board, but you have it coming from the thermostat, it's probably your board. Remember, we talked about and when we talked about the defroster board being bad. So we're past that. So we should have voltage here, but that's not kicked in. Well, that's your coil of this contactor is bad. All right. Now, if that coil's kicked in and you still are not getting fan blowing and compressor working, the next step to do is check your voltage, right? So we're getting voltage to these black wires. Your contactors, the button right here is pushed in. You can see it pushed in. I hope you can see that right there. Little square, see that little square? That is your button. That should be sucked in. There should be a little hole there telling you that the coil is sucked in. If that coil is sucked in and you still is not getting the fan turn and the compressor is not working, both of those together, then what you want to do is check for voltage across the contacts, which means I told you a minute ago that the contacts may be corroded and it's not, voltage isn't passing from here up to here, right? So how do we check that? Easy. It's very simple. So over here, this is called a single pole. And the reason it's called a single pole contactor or single pole relay is because, see this over here on this red side? I'll get you in there. See, there's a metal rod. Let me see if I can get in here to show you. There's a metal rod going up the side here. See that metal rod between that bolt and that bolt? That's always going to be power, right? So if you measure this side over here to the frame of the thing, you're going to get 120 volts because that's always connected. Remember, it's a metal rod going up through there. See that metal rod up through there? There's always power there. No matter if this is sucked in or not, this little square, there's always power on that because that's called a single pole. What does that mean? It means it has one side that contacts this side. This side is the contactor side, right? This is the one that gets sucked in. This other side's always on. Now, there's a double pole relay too. If your unit has that, then you'll have a little square on each side, here, over here, and over here. Both of those will need to be sucked in for it to work properly. Again, you'll have 24 volts here. Those are sucked in, meaning the coil's working, but you've got no fan. So what you want to do is check voltage. You're going to check, you know you got voltage here. You just put a lead here and here. Those two together should say 240 volts. Then to go farther, because remember this is solid over here on this side. This side is the one that's contacted. We need to know if you put two prongs here, you're probably going to get 120 volts. You may think, well, it's working. Well, it may not be working because if it's only 120 volts, that means this side isn't contacting, even though that's sucked in, right? So you want to measure them independently, and what I would suggest, put a lead to the black, and then ground it out over here. You should have 120 volts when you do that to these 2 points, here to here. Then you can put a prong on the red over here, then to the frame. Those two should say 120 volts. Then, since that's sucked in, and the coil has 24 volts, the coil is working, but you still don't have nothing out here, you'll go up here on the top side of your relay, okay? You'll take a prong here on this side and ground it out. You should have 120 volts because that's sucked in now, right? So that means the voltage can pass from bottom to top. This side's always solid, so you know if you put a prong there into the ground, those two, that's going to give you power because it's a solid connection, right? This is the ones in question. If you got a two pole, you'll have to check both of them. But if you only got a single pole, you really only need to check the one that's got the button on it because that's always solid. So you put a power lead here from your meter and a power lead to the ground. Now, 99% of the time, if that's sucked in, you still don't have nothing working, you won't get no voltage here, or you'll get very low voltage, meaning those contactors inside there are dirty. Either way, it's going to need to be replaced. So now you say, okay, I figured out my relay is bad. How do I go about replacing that, Wayne? It is one of the simplest. It's simple as replacing a capacitor. Those two tests I just showed you is the best way to check that relay. Very simple. You still have the coil working fine, but the contacts inside that coil is corroded over, and it won't be making no juice. It won't be flowing. So what you'll do is, as before, make sure you take a picture of all your wires. See, there's 3 wires on the bottom. One's a little black wire and a little prong plugged in. That's those. You'll take those 2 wires out, that wire out, these wires up here. Take good pictures of everything. Go to the side here and make sure you take pictures of everything. If you have to label them, that is perfectly okay. Take pictures of your capacitor too, because sometimes when you get in here wiggling all this around, you'll unplug other stuff. So take pictures of everything, but the main thing is take pictures of that. Now, what you want to do, once you get that thing off, you're going to zoom way in here closely. Hope this thing will focus for you. Let me see here. There's going to be a bunch of numbers on this. There's ratings on there. It's going to say a bunch of stuff. It's the same thing as capacitor. You want to match up what the capacitor says on it with what this says. So if I can read this upside down here, since I can't get this thing to focus for you, I can't really read it. Anyway, it has a FLA number right here. I hope you can see that. And I can tell you what that stands for, but there's no really point in it. Don't worry about it. It has a FLA number. Look, you'll need to match that FLA. All these numbers in this little square box right here. You see it here? All those numbers is what you want to match up. Let me see if I can zoom in a little bit. Yeah, there we go. See the FLA number? Mine's 32, right? And it's going to tell you VAC. That's voltage AC. That's 20 amps at 200. And I can't read this upside down, but anyway. And then all that stuff you want to make sure it's the same. It even has a model number here, right? You want to match all that up. Get on Amazon, it has these. The heat and cooling places have these. Order that thing up, put that on there. That should fix your problem. Try it again. The main important thing is disconnect your power before you ever start on any of this. Now, you'll have to have this power on when you start diagnosing this. Just don't touch anything. Please be very, very careful. You know, this is 240 volts, and if you're standing in water, that can hurt you very badly. Don't touch it while it's on. Just use your prongs, right, on your meter. Touch them in there, one over there on the ground, one on your lead, just touch it. You'll see your voltage. Don't be afraid to do that. That's perfectly okay. Just don't touch the prongs themselves. Don't touch those screws themselves. Stay away from that, right? And once you figure out that it's bad, then go over here, disconnect power out here. Also, go inside and turn power off inside your house that controls your thermostat, because what can happen, that thermostat, because the thermostat's on a different set of breakers, and you want to turn that off. It'll say like air handler or heat pump or something in your house. You'll want to turn that off, because that thermostat can still send a call for service out here for power. So it'll send 24 volts, keep the board on the board, keep the relay on, and you may have some residual charge somewhere that may zap you. All right, so cut that off inside so you don't get an accidental charge from the thermostat inside. Okay, so make sure you take that power loose always, always, always. Yeah, I say every video, be very careful. And remember, if you don't feel comfortable doing this, then call an AC guy. If you feel like you can do it, you know, you can do this. You gotta just be very careful. Be very careful. Don't be distracted. Don't be, you know, trying to do this, do something else at the same time. Focus on this. Be very careful when you put your prong. Just slide your prong in there. I'll show you what I'm talking about right here. So if I turn my meter on, I set it up here. Hopefully I can see it so you guys can see it. All I'm going to do is I'm going to come in here. Just see, there's my meter. We might turn it on the appropriate thing here. That's going to be AC, which is alternating current. So if you turn your meter, see this little mark right here? It's got the squiggly mark. That means alternating. The direct lines mean direct. Mine goes to 700 or 200, so we're going to do 700 volts. So what I'm going to do here is I'm just going to simply, see this little hole back here? I'm going to hang this lead in that hole, like that. See, now I'm not even having to touch that lead. And I'm doing this with one hand. So if I can do it with one hand, you can do it too. I'm just going to barely come in here and look where my hands are. See where my hands are? Don't put your hands up on this lead up here. Put them way back here. That's why this ring is here, to keep your fingers away from that. Touch it right there. That's all you got to do. See? That's it. That's all you got to do. Then same thing over here. Touch it right there. See? That's all you got to do. I don't got to do nothing else. Actually, I didn't have my meter set on. I can't hardly see out here in this bright sun. I'm looking right at the sun. It's blinding me, so I can't really see where my meter is. Like the other day, I thought that said 200 microfarads. It actually says 200 nanofarads. Either way, yeah, I got it set on 700 now. So just to reiterate that, we're gonna put this in that little hole, the black lead down there. See that? Let it hang there. That's fine. And then I'm gonna come over here and stick this to one of the leads. See, I'm just putting it in there. See up here on my meter, 120 volts. See where my hands are? Way away from everything. Because you have to have that power on to see if you're getting power on this relay. Because you may have a problem between here and the wall. You may have a broken wire. You may have something blown somewhere. It may not even be the relay. You got to know if power's coming here, right? Then I'm going to go over here to do the same thing. Just touch this over here. And look, 120 volts again down there. See where my ground's just hanging in a hole. If you don't have a hole, that's okay. You'll have two hands. I've only got one hand right now because I'm using the ground. I'm using the camera. So I've got one hand on the red, and then I could probably do it with one hand even if I really wanted to. Let me try it. Just to show you guys can do this. Don't be afraid of this. But if you feel at all like, oh, I really don't want to fool that way, and that's okay. You don't have to do it. You don't have to do it. Hire someone. See, I got that there. Look, one hand, 120 volts, and there we go. See, I'm not touching anything. Just keep your hands back. And once you get the relay and you diagnose it is the problem, then you can turn the power off, pull that breaker like I show you in every video. And as I said earlier, take the breakers off, turn them off inside, and make sure there's no power that can come out here. You don't want anything on. See how it's got a little light there flashing? It's waiting for a call for service, okay? It's waiting for, to get a signal from the thermostat to say, hey, kick the unit on. You don't want to see that at all. You don't want nothing showing there. That means you have no power out here at all from the thermostat. That's what you want to see. I hope this video has helped you. And I pray that I've said something and helped you. And like I said before, I don't mean to offend anyone. I'm just trying to help folks out. And I would pray that everybody else try to do the same. Now, I will do one more video, probably, and briefly discuss what can happen. And actually, you know what? I'll tell you right now. If you don't get 24 volts out here, it could also be one other thing besides the board. There is a transformer inside the air handler inside your house. That also sends the 24 volts out here. I mean, it has to come through that first. It reduces the voltage down. And so that could also be bad. It may not be sending the 24 volts it needs to send through the thermostat and then out to here. So that could also be the problem because remember, that's house voltage, 124 volts, 120 volts AC. That can't go through the thermostat. It would fry the board on the thermostat just like it would here. So it goes through a step-down transformer first, which is located usually inside your air handler in the house. That could be the problem as well. But you'll know because you won't have 24 volts here, right? But you'll know that you won't have 24 volts here. If you have 24 volts here, everything in the house is good, right? So it's going to either be your board or your relay. If the board's good, we showed you how to test, first ways to test it. If it's getting the call for service and it's sending out the H1 and C1 and all that, it's probably good. And especially if you're getting 24 volts up here, it's good, right? So it's probably, then it's going to be your relay, right? And if the relay is working good, it's probably the capacitor, and I showed you how to test that. So the next video, what we'll do is I'm only going to have one more. My brother-in-law across the way here, he has a heat pump that the outdoor unit won't come on. What we're going to do is I'm going to walk through it with you guys. We're going to try to take everything we've learned so far and we're going to apply it to his heat pump. I have no idea what's wrong with it. He has had no one to look at it. I haven't looked at it. He's been using emergency heat the last few days, and I told him I'd get to it this weekend where I work a full-time job. It's kind of hard to do that and do other things too, but I'm going to go over and look at it for him this weekend, probably in the morning, and I will walk through it with you guys, and we'll see that if we can figure out using what I've showed you to figure out what's happening, where would I, and I'll show you where I'll start at. There's a certain way I like to start. I like to rule the easy things out first, because if that's the problem, and you find it right off the bat, then you're done. So I usually start with a relay or the capacitor. That's where I usually start at, those two, because remember I told you probably 90% of the time it's the capacitor, and then the other 10% of the time it's probably the relay. Those two are the most common ones to go out. That and more than anything. And so I'll start those two because that's usually the problem. That's not always the problem, but it usually is. So we'll start there and we'll go through it together. And I pray that you've had a blessed day, and I pray you've learned something from this video. And please, I welcome all comments, even comments that give me a hard time and don't like me and say all these negative things about me. That's okay. I still welcome your comments because everybody has their right to opinions, right? All I ask is be honest, try to help folks out, try to be respectful, and try to understand that, I may not talk like you, I may not say the same things you say, but I want to get the job done. I want you guys to be able to get the job done. I pray that you have a blessed day, and God bless you. I'll see you on the next one.